So, good day, guys. Welcome to today's lesson. In today's lesson, we are going to be talking about the support type. Okay. So now, before let's look at it in 3D first. Okay. So now, what we need to do is, okay, I've extruded it. This is to extrude it. You can see the shape in the extruded version. I can turn it off and be using that. Okay. So now, what we need to do is to place the support type in ETABS. Now, before we do that, let's make sure everything is on one story, because if we decide to make it, let's go to plan, ground floor, and let's say we forgot that uh, it was on all story or similar story. Once you highlight this support, it will highlight all the old joints in the structure. So you'll be placing support there where you're not supposed to place support. So all you need to do is change it to one story, and let's go back to the plan. Okay. So let's go to plan, ground floor, click OK, then highlight the base so you can see it, just 20 joints selected. So what we need to do now, let's go to assign joints, then let's go to, sorry, then let's go to restraints. So we are going to be assuming it as pinned support. You can decide to assume it as fixed support. There's nothing wrong. The only problem you have is that if you start your assumption or your analysis with fixed support, and they've got to start decide the foundation, and also there is now a change modification, and you want to rerun the analysis, the problem is you cannot run back to start changing it to pinned support, or from pinned to fixed. You cannot do that because you are already changing your assumption and you've assumed it as pinned initially. But I prefer to assume mine as pinned because it is easier. It gives a lighter foundation size because it is only the gravity load or the axial load that is coming to the foundation. But if it's fixed, it's going to be the axial and moment. So to get the stress in the foundation for axial alone, that is for pinned, it's just going to be the total axial load divided by the area. So it will give us footing pressure. Then if it's for with moment, it's going to be P over A. So P is the axial load, A is the area of the footing, plus or minus M over section modulus, M over Z. So it's going to give us both positive and negative. So you take the adverse unfavorable effect. So that's the reason why I prefer to use pinned. It's easier to construct and it's lighter. So click OK. So now we can see our structure is fully pinned. So select it, right click, and let's go to assignment. So you can see the restraint is in X, Y, and UZ. But what will happen if it's in fixed? Now let's highlight this and let's go to fixed. So come here, restraint, and let's choose fixed. So this is fixed. Okay, select it and click OK. So select one of the joints and right click on it and look at it. So it is fixed in both translational and rotational. So but if it's pinned, it's just going to be in translation. It won't move, but it can rotate. So highlight the structure and go to assign this restraint and choose pinned. This is for roller, this is for just free. It is free. So if you choose roller, your building is going to be unstable. So but to move in the Y and in the X direction. Okay, so let's pin it and click OK. So we've pinned our footing. So there's nothing wrong with you as the engineer fixing it. I will even advise you to fix it if you know you will continue fixing it till the end. Okay, now another way of doing it, which we'll be doing in the future videos, is you can see what we have here, or let's come to define, and you can see spring properties. So you can see we have point spring, line spring, area spring, soil profile, and isolated. So you know that your the load transfer in your structure goes in a way of stiffness. So if you have a stiffer member, more load goes to that member. So you notice that when you have a shear wall and you have a beam, you have bigger moment than shear forces there because more load is going to the shear wall. The shear wall is more stiffer than the columns. Okay. Now the thing is, our footing too, if you have a footing size of 1.2 meter by 1.2 meter by 300 millimeter thick footing, the load coming to that will be different from having that same column and having a bigger footing of 1.8 by 1.8 by 450, because they have different stiffnesses. So stiffness attracts more load. So that's just the way it is. You will see when we bring our shear wall in, what we will have. So now when we get to the foundation, that's when we'll be using this one. But in this case, we'll just use this to get an approximate foundation size before we place the real foundation and get our soil pressure to see if it is okay. Okay. So now what we've done is to apply the support on our base. So you can just right click again to confirm, and let's see what we have. It is fully pinned. Okay. So now we are done with today's video. In the next video, we'll be running the analysis and checking the post-processing. So if you have any question, you can drop it in the comment section. Thank you very much.